Okay, now let's see. Start with the base case example. If we find LOE in empty, that's false. That puts a false here, which of course makes sense. If you're looking for something in nothing, you can't find it. Now here's a case that says if we're looking for F3 and F1, we don't find it. If we're looking for F3 and F3, we do find it. So it seems like that when we're looking at an element, there's kind of two cases. This is the case where we find it right away. Right there and right there, we find it right away in those two cases. And then there's the case where we don't find it right away. So that suggests an if in find dash dash element. And the question is, is the name of this current element the name that we're looking for? So both names are a string. This nice little note here that I put in the template reminds me of that. Is the name of this element the name I'm looking for is the question. One thing about this little note I put in the template, in some other kinds of programming languages and in more sophisticated programming environments, this would be automatically given to you. You could just kind of hover here and it would say, oh, that's going to produce a string. So we're just replicating a feature that you might get in some other languages already. I like putting it here explicitly to help you understand kind of where it's really coming from. We'll delete it now. So let's see, if the name of the current element is the name we're looking for, then what are we supposed to do? Well, we're supposed to produce that element's data. So there we go, we'll just produce its data. And if the name we're looking for isn't the current element, well, what are we supposed to do in that case? Well, these other examples are saying that you keep looking. We got to go look in all the children. In other words, we got to do the natural mutual recursion. And we should follow the standard advice, which is to trust the natural mutual recursion. This is going to go look in the children, and whatever it produces will be the answer. Now let's go down here. Now we're looking at a list of elements. And we don't actually have an example for this. So let's put in an example for this. Let's say check. I'm going to put it right here because it's really a little bit simpler than the D4 example. I'm going to say find element, find dash dash LOE, in cons F1, cons F2 empty. This is the subs of D4. Okay, this is the subs of D4. So actually, I'm not putting this in the right place. I should really be putting this up here. This is the subs of D4, and I'm finding, what do I want to find in there? Let's say I want to find F2. Can I find F2 in there? Yes, that should produce 2. And we'll add another one. Can I find F3 in there? And the answer to that is false. And now I can really understand that these examples all have a bit more structure. There's really the base case example. There's the has no children examples where we're looking in F. We're not looking in anything that has children. And then this example here is a quite similar example because I'm moving it up here now because it's really an immediate success example. This doesn't go look in the children. So we look in nothing. We look in things that have no children. We don't look in the children. Here we look in lists of children. And now we start looking in things where we have to look at the element itself and its children. So now I've got the examples ordered more in terms of their complexity. And so find dash dash LOE is really kind of here and here.